Hi everyone, and welcome to the first video tutorial series on using 3D manufacturing format extension. In this video series, we are going to explore 3MF extension and create an application to load and visualize a 3MF model. So let's start. What you see here on my screen is the application that we are going to make throughout this video series. This is a very simple application that lets you load a 3MF model using import dialog and display it in our scene. In this case, I'm using the statue model that I've downloaded from Sketchpad. Alright, so here is the link to the model that we just loaded in our application. When you go to the download section of this model, you can only see OBJ format. This is totally okay because later on I'm gonna show you how to convert your OBJ files to 3MF, and there are a few apps out there that would allow you to do that. So now you may ask yourself, why would we need another format? As you already know, there are many different file formats out there. To name a few, STL, OBJ, or FBX files. Unfortunately, none of these models are ideal for anyone who wants to 3D print a 3D object. The 3MF format is actually designed to be a much better solution to replace all these formats and make it much more easier and more efficient to 3D print 3D objects. As we go further through this video series, you will see how powerful this format can be. Now, if you are a 3D game or graphic programmer, or even someone who is making 3D prototypes, you should still be able to take advantage of this format. And this is the main goal of this video series. There are many details involved with 3D-MF which are purely related to 3D additive manufacturing, and we won't necessarily need to use them in this series. The main goal here again is to understand the format, extract mesh information, materials, textures, colors, and visualize them. Here is my notebook where I've put together some of the notes and links that are related to our video series. I will go through some of these notes in more details in later videos, but for now the first thing is to take a look at 3MF official website. This is the official website for 3MF, and if you go to a specification link, you will find detailed documentation on 3MF core specification and reference guide. In later videos, we will have a close look at some of these documents found in this webpage. Now, if you scroll to the bottom of this page, you can find a link to the open source library on GitHub. So here in this page, you can find the nightly binary builds as well as the full open source code for 3MF extension. If you go to Lib3MF SDK link, you can find the binary SDK with several examples. We will look at this zip file in a short moment and some of the examples that are in this file. Okay, so let's go ahead and download lib3mf sdk.zip and have a look at some of the example projects that come with this. So I'm just going to extract it here. And as you can see, there is a folder called examples. Inside examples, you can find some sample 3MF files and some textures that are being used with these sample projects. You can also find two scripts here that would generate Visual Studio and Xcode via CMake. So I'm just going to go ahead and run this generate Visual Studio 2015, and that's the version of Visual Studio that I have installed on my machine. Alright, so let's go ahead and open up examples.solution. And as you can see here, there are a number of sample projects that come with this solution, and the project that we are interested for now is called extract info. So I'm just going to right click on this and set it as a startup project, and next I'm going to build this. So I'm just going to build it. So basically what this project does is you pass a 3MF file via command line, and this program will print out some information about object properties, mesh information, or thumbnail information, and some additional information that are related to 3MF. This is actually very useful, and we will use some of the code in this project when we write our own C interface 3MF loader. So I'm going to go ahead and open up Git bash, and I'm going to go to the directory where the executable for this project was created. And as you can see, this is where the executable was created. So what we need to do right now is to pass the helix.3mf that's inside a files folder. So what we need to do right now is the executable is actually sitting inside debug. So we have to go back 2 folders up to get access to files, and then we pass helix.3mf. So I simply call examples extract info.exe, and then I'm gonna go 2 folders up inside files folder and passing helix.3mf. Perfect. So what you can see here is this program printed out some information about our helix.3mf. In this case, this 3MF file comes with one mesh, and as you can see, we have printed out some information about vertex count, triangle count, mesh name, part number, as well as build item here. Again, in later videos, we will have a close look at some of these properties that was printed out using this program. Alright, so let's talk briefly about some 3D applications that you can use to convert your OBJ files into 3MF format. The first application that we are going to talk about is called 3D Builder. 3D Builder is a free Windows app that was created by Microsoft, and it lets you view, repair, and prepare your mesh for 3D printing. 3D Builder also imports and exports popular 3D formats such as 3MF, OBJ, and STL files. If you are already familiar with this app, you can simply skip this section and move on to the next step. So I'm going to go ahead and run 3D Builder. And then I'm going to create a new scene. And as you can see here, 3D Builder comes with a very simple user interface. Now, if you go to the Insert tab, you can simply add simple geometry such as cube, cylinder, pyramid, cone, etc. You can simply click on these shapes. So I'm just going to click on cube, and it will add it to the scene that we have. You can also translate, rotate, and scale your model. Now, the next thing I'm going to do is I'm going to remove this cube from the scene, and I'm going to go ahead and download the statue model that I showed you earlier in this video. So I'm going to go to the Sketchfab website and download our statue model. Okay, and then I'm going to extract it here. and then I'm gonna load this statue.obj into 3MF and convert it to 3MF. So you can go into the insert tab, click on add button, and simply select load object, and then inside downloads source I'm gonna load these obj files. Okay, as you can see, this model comes with texture, so I'm gonna select import model, rotate this. So I'm just gonna rotate this model 180 degrees. Alright, and then the next thing I'm gonna do is I'm gonna go under paint tab, select color, make sure the coverage slider is at 100%, and then I'm gonna simply select the blue color and assign it to this model. The next thing I'm gonna do, I'm gonna go to the save as and select 3MF from this menu. As you can see, you can save this model as STL, OBJ, or PLY. So I'm just gonna select 3MF and save it on my desktop. Again, I've already saved this model on my desktop, so I'm just gonna simply replace this. And here you have it. Here was one way I showed you how to convert your models to 3MF. Alright, so the next application that I'm going to show you is called Autodesk NetFab. And basically NetFab is a more sophisticated and advanced application than 3D Builder. It also offers more powerful tools and features that makes it easier for you to 3D print your models. So I'm going to go ahead and show you the official website for Autodesk NetFab. And here you have it. This is the official website for Autodesk NetFab. And basically, inside this page, you can find useful information about some of the powerful features that comes with this application. In here, you can also see that you can download the free trial version of this app, which obviously comes with limited functionalities. In this video series, I won't be using Autodesk NetFab for sake of simplicity and would let you explore this powerful software on your own. Alright, so let's quickly talk about 3MF file format itself. In a nutshell, 3MF is an XML-based data format that comes as a single package like a zip file that contains information such as mesh, textures, materials, colors, units, etc. 3MF format uses a number of technologies such as Open Packaging Conventions, or short for OPC, zip, and XML, which makes this format human readable. Now, let's have a quick look at what Open Packaging Convention is. Now, if you search for OPC, here is what you can find on Wikipedia. As you can read here, OPC is a container file technology initially created by Microsoft to store a combination of XML and non-XML files to form a single document. That's pretty much what OPC is all about. Now, if you scroll down a little bit in this page, you can see that we have a section where you can find some of the file formats from different applications that use this technology. Obviously, as you can see here, 3MF is one of them. Also, Autodesk AutoCAD Design Web Format uses this same technology. Now, if you scroll down a little bit more, you can see that we have a section that talks about package, parts, and relationships. Now, these are very common terminology when you use OPC. In a short moment, you will see that every time we unpackage or unzip a 3MF file, you will be presented with some of OPC specific directory and files described in this section. Now, keep in mind that I won't be going into details of OPC library or implementations since it's not really relevant to this video series. Now, let's go ahead and have a look at some of sample 3MF files that I've created already. The sample files that I'm about to show you have minimum geometry and resources data, which makes it very ideal when we are doing debugging. Okay, so the first model that I'm about to show you is called cube-based-material.3mf, and I'm gonna go ahead and quickly open this up using 3D Builder. Now, in a 3MF terminology, base material is simply a solid RGBA color per triangle. In this case, we have a red material assigned to all the faces of this cube. Now, as we talked earlier, you can think of a 3MF file as a package or a zip file. So if you have 7-zip or WinRAR, you should be able to extract the content of this 3MF file. So I'm going to go ahead and extract this cube-based material. Okay, so inside this folder, we have a directory called _rels and also a file called contenttypes.xml. As we saw earlier in the wiki page, these two particular directory and file are specific to open packaging conventions. Now, in addition to these two, we also have a directory called 3D and metadata, and these two directories are specific to 3MF, and that's what we really care about. Now, let's go ahead and open up a metadata folder. And inside here, we have an icon called thumbnail.png. This is pretty much the thumbnail for your package. As you can see here, this 3MF file has this icon that grabs its thumbnails from this metadata folder. The next important folder inside here is called 3D. And inside 3D, we have a file called 3dmodel.model. So 3dmodel.model is an XML file that contains all the data about your 3D model. Now, every 3D model.model must have a root element called model, and the root element must also have two children called resources and build. So as you can see here, we have a root element called model, and this root element comes with two children. One is called resources, which is from line 3 to line 40, and the other children is called build, which is from line 41 to 43. In later videos, I will go into detail of each one of these elements and will show you how to parse this data. Now, let me go ahead and show you the next model. So this model is called cube color group.3mf. So let me go ahead and open this up with 3D Builder. All right. So let me also turn off this wireframe. Now, as you can see, instead of a single color now, we have a nice color ramp. In 3MF terminology, this is called color group, which is simply a per vertex color. Now, let's extract the content of this file. Okay, and as you can see here, this particular 3MF file does not come with metadata folder, which is fine, and there is nothing wrong with that. So let's go ahead and inside 3D open up 3dmodel.model, and as you can see, we have a root element called model. We also have our two children's resources and build. And under resources, you can see that we have a different name called color group. As I said, a color group is a per vertex color. And in this case, a color group comes with 3 unique colors. Okay, so let's move on to the next model. The next model is called toTextures face.3mf. So here in this case, we have 4 faces with 2 different textures, and every 2 faces share a different texture. So let me put on this wireframe, and here are 2 faces with this particular texture, and the other 2 faces have this particular texture as well. Very simple model. Now let me go ahead and extract this file. Okay, and let's go inside 3D. So inside 3D folder, you can see that we have an additional folder called texture, and simply this folder holds all the textures that this model is using. Okay, now inside 3D model.model, you can see that under resources, we have this additional names called texture2D and texture2D group, or I should say different names, not additional. The first one is called texture2D, and texture2D is the name of the texture that we have with the unique ID. In this case called wood.jpg. The other texture that we had was moldy diff.png, and this one has its own unique ID as well. And underneath this, we have our texture to the group, or basically UV coordinates. So for texture ID 3, we have this specific UV coordinates, and for texture ID 4, we have this specific UV coordinates as well. Now, this was a very quick introduction to 3MF file format. If you download any 3MF model from internet, you will most likely see a combination of base material, color group, or texture. Again, I would like to remind you that there are many other information in regard to 3MF and 3D printing technology which I did not cover in these videos, and it's simply because we won't be using them, and it's not really the goal of this video series. Also, it's important to know that different 3D softwares export 3MF a little bit different than the others, but nonetheless all of them must follow the specification that is defined by 3MF Consortium. So don't be surprised if you see different 3D applications export 3MF differently. Okay, so the next step is to set up our project and try out Lib3MF library. I'm gonna go ahead and open up my notebook to have a look at our checklist. Alright, so we already talked about 3MF technology and what 3DMF is all about. So I'm just gonna go ahead and check off this section. A few things before we start our project is, first of all, we are gonna use a CMake for our build system. And the second thing is that our project is gonna be statically linked to all the libraries that we are gonna use. So as you can see in this section, I have listed all the libraries that we are gonna use throughout this video series. So I'm gonna check this out. The next thing to remember is we only care about the 60-bit version of our program, and I'm simply gonna ignore the 32-bit version. Another thing to remember is that we are going to use angle brackets and not double quotes, and you will see why in later videos. I like this style better. We are also going to make sure that our program is going to run on both Visual Studio and Mac. Okay, so the next thing that we obviously need is our Lib3MF library. So let's go ahead to GitHub and download it. Alright, so from the master branch, I'm just going to go ahead and download this library as zip file. Okay, so pretty much all the source code that we need to use this library are found inside include and source directory. We also have the CMake list set up for this library. So if you open this up, you can actually find the code for creating both a static and shared version of this library. Now, to simplify things, we don't really need to use all this code here, except the part we are creating the static library. We also don't really need to bring over any of the other folders or directories that are found with this inside this Lib3MF master. Now, before doing that, there is one more thing that we need to do. If you go inside include model com, you can actually see that we have this nmr conversion.header.in. This is pretty much a header template which basically relies on some CMake configuration that we have inside release version info folder. So if you go back in Lib3MF master, inside release version folder, you can actually see a CMake file that pretty much generates the product version. Since we are not using this CMake function or module, and to simplify things, I'm just going to go ahead and rename that header template and add the product version manually. So I'm going to go here inside include model. I'm just going to rename this. So I'm just going to get rid of the .in. And I'm going to go ahead, and if you look at the website for Lib3MF, you can see that we have the official release. So inside here, the latest release is 1.1.5. Okay, so I'm just gonna go ahead and change the Lib3MF major and minor and micro. So this is gonna be 1 for the major, 1 for the minor, and 5 for the micro. And that's pretty much all you need to do inside here. Also, if you look inside here, we have this .ignore, and inside here, this file is being ignored. So I'm just gonna go ahead and delete this. Okay, so I'm just gonna delete this. And with this, we are actually ready to copy over both include and source to our external directory Lib3MF. So I'm just going to go ahead and copy this to folder. And let's go into Explore 3D, source, external library. And inside Lib3MF, I'm just going to paste these two folders. Okay, so the next thing that we need to do is to set up the CMake for Lib3MF. And for that, I'm gonna bring over the CMake list.txt that we had inside the Lib3MF master folder. So let me put this on another tab. Okay. And let me go ahead and create the CMake file inside Lib3MF. Okay, so the first thing that we are going to add is we are going to include the CMake file that we have inside the source folder. So I'm just going to add this, and as you can see, there is this CMake list files, and inside here we have this variable which holds all the CPP and C files that are inside this folder. So I'm just going to go add that here. If you look here, you should be able to find it. So this is where we brought in this code to our CMake list. Now, the other thing that we need is if you go to the static library version, we have some code that we are going to use. So I'm just going to go ahead and copy this. And this is going to add our static library. So I'm just going to go ahead and rename this to Lib3MF. So this is going to be a static library, and I'm just going to pass in the source comments or sources comment. Okay. The next thing we need is some target include directories. So I'm just going to go ahead and copy them over. Again, I'm just going to rename the file, the library name. Okay, so that's done. And if you notice here, we also have some compiler warnings or some compiler options. So I'm just going to go ahead and copy them here. Okay, and I'm going to rename again the library name to Lib3MF. Okay, and at this point, I don't really care about other non-Windows platforms. Later on, we are gonna set up the CMake for Mac and make sure that our project can actually run using Xcode. So I'm just gonna leave it as is for now, and with that we are pretty much done with setting up CMake for Lib3MF. Now, the next thing that we are gonna do is we are gonna go back to 3MF app, and we are gonna set up a CMake for our executable project. So inside 3MF app, I'm just gonna go ahead and create a new CMake file. Okay, and let me close this since we are not going to use them anymore. Okay, so let me go ahead quickly and add some CMake commands. Okay, so the first thing I'm adding here is our project name, and we are gonna pick up the name from the directory. In this case, it's gonna be called 3MF app. Okay, and then I'm gonna globe all of our header files and CPP files that we might wanna use. So just gonna add this. The next thing that we need is our executable. So our target executable is our project name, and we are going to pass in the source files. And the next thing that we need is to include the Lib3MF header files and also link it to our project. So this can be simply done using target include directories and target link libraries. So I'm just going to quickly add these two. All right. Okay, and that's it. So with this, we should be able to we should be pretty much done with our CMake setup for our executable project. So Now let's go ahead and write a quick program to output Lib3MF version to console, and this way we can be sure that both compiler and linkers are happy, so we can start using Lib3MF library. So inside a 3MF app, I'm just going to go ahead and create a new file called main.cpp. And let's go ahead and start coding for our application. Okay, the first thing that we need is we need to include model com nmr dll interfaces.header, and this is pretty much holds all the header files that we need to use this library. Okay, the namespace for Lib3MF is called NMR, so I'm just going to add that. I'm also going to add IO string. Okay, put this here. Okay, so let's go ahead and add some variables. So let's put keyword. So we are gonna simply print out a major, minor, and micro version of Lib3MF. Okay. And I'm gonna simply call Lib3MF get interface version. I'm just gonna pass in those variables. So I'm gonna pass in major. I'm gonna pass minor version. Also going to pass a macro version. Okay, so the next thing we are going to do is we are going to simply output these numbers or these variables. So Lib3MF version. Going to be major version first. Okay. Okay, so we are done with our simple program, and let's go ahead and let CMake to generate Visual Studio solution for us. So inside Explore 3D, I'm gonna go ahead and create a directory called build. And basically this directory is gonna hold all the binary files as well as Visual Studio solution. Okay, so let's call CMake to generate a Visual Studio solution. And this is going to be a 64-bit version. Okay, so CMake was able to configure and generate our Visual Studio solution. So I'm going to go ahead and open up explore3d.sln. Okay, so as you can see, we have a Lib3MF target project, which basically creates a Lib3MF static library. We also have our executable target project called 3MF app. Now, before running this app, I'm gonna add a cmake command to basically put all underscore build and 0 underscore check inside the folder. So our solution is a little bit less busy. So the command that I'm gonna call is called set property. Okay. Now let's go back to bash and let's call cmake again. Okay. And inside Visual Studio, let's click on reload all. As you can see, we now have a folder called cmake predefined targets, and both all underscore build and 0 underscore check are gonna go inside this. Great. So the next thing we are gonna do is let's go ahead and set 3MF app as a startup project. And with that, I'm gonna go ahead and build our solution. Great. So let's go ahead and run 3MF app. So I'm just gonna press Control F5. And as you can see, this program outputted the current version of Lib3MF, which is 1.1.5. Great. So before wrapping up this video, I'm gonna go ahead and run our app on a Mac machine and make sure that it runs with Xcode as well. Alright, so we are now on a Mac machine and we need to make a few changes in our project to get things compiled and running. The first thing that we want to do is to support a specific C++ standard in our application. And in order to do that, I'm going to go ahead and inside our cmake list.txt, which is in our top source tree directory, I'm gonna set our cmake cxx standard to 14. So let's add this here. All right, and again, later on, we will create a separate CMake module where we add more compiler flags for different operating systems. But for now, I think this should be good enough. Now, another thing that we need to change is inside apps main.cpp, we are using backslashes for this inclusion header, and this obviously won't work on a Mac. So I'm just gonna go ahead and change this to forward slashes, and this should also work on a Windows machine as well. The next thing that needs to be changed is inside Lib3MF folder in cmake list.txt, we added some target compile options, and all of these compiler options are only specific to Visual Studio. So I'm just going to go ahead and wrap this inside this if statement. If this is a Visual Studio, then we are gonna add this target compile options. So let's go ahead and add it here. Right, so that should do it. All right. Let's go ahead and run cmake to generate our Xcode project. And let's go inside this. And what we want is we're gonna call cmake, and we will gonna generate Xcode. And we also need to pass a flag to make sure that we are building only for 64-bit. So we pass this flag, which is cmake x architectures. Okay, and that should do that. So let's go ahead and run this. Alright, so the configuration and generations are done. And let's go ahead and open up our Xcode project. Alright, just going to go ahead and build this whole project. Great. So the build was successful, and let's go ahead and switch to our app. So I'm just going to go over here and switch to 3MF app. Okay. And let's go ahead and run this. I'm just going to go ahead and run this. Great. So I'm not sure why it took a little bit of time to run this, but as you can see, we have our Lib3MF version 1.1.5 printed out in the console. So great. So this should conclude part one of this series, and hope to see you in the next video. Thank you.